This is video 3 of looking at cross products part 2. So we're just going to talk about this little piece down here, which is a little consequence of this formula that we just talked about. So it says a consequence of this formula, and the formula that we're talking about is this formula up here. Right, the fact that the magnitude of the cross product is the product of the magnitude sign times the sign of the angle between them. So a consequence of that formula is that if A and B are non-zero vectors, then it says that A cross B will be equal to 0. And I want to emphasize this is the zero vector. Remember that a cross product is a vector. It's not a scalar. So it's the zero vector if and only if vector A is parallel to vector B. So we're going to start with, so remember we talked about this the other day, that whole if and only if means that we can take this both ways. So in other words, it's saying that if the cross product is the zero vector, then vectors A and B are parallel, and then vice versa. If A and B are parallel, then their cross product will be the zero vector. So we have to prove it both ways. And again, I won't expect you to do this on a test, but I do expect you to be able to follow it. Because, and again, I think it reviews some good things, that watching and listening to the proof reinforces some of the ideas that we've been talking about. Okay, so if we start out with the fact that, I'm going to do a different color here. We start out with the fact that A cross B is the zero vector, right? So then that means, therefore, the magnitude of A cross B, is 0, is the number 0, right? Because the cross product is the zero vector, the magnitude of the zero vector is 0. All right, so therefore, we know that, and this is because of this formula, that the magnitude of the cross product is equal to the magnitude of A times the magnitude of B times the sine of theta, the angle between them. We know that this is 0, so that means therefore 0 is equal to the magnitude of A times the magnitude of B times the sine of theta. And now we're multiplying three things together, 1, 2, 3, and it equals 0, so that means therefore one of them has to be 0, at least one of them. So the magnitude of A is equal to 0, or the magnitude of B is equal to 0, or the sine of theta is equal to 0. But remember we said up here that A and B are not zero vectors, so that means these can't be true. All right, the only vector that has a magnitude of 0 is the zero vector. All right, so this says therefore sine has to be 0. Well, if you think about your unit circle, where's the sine 0? The sine is 0 here and here, because this is 1, 0, and this is negative 1, 0 on the unit circle. Sine is the y-coordinate. So therefore theta is equal to 0 degrees or 180 degrees. Well, what are we trying to prove? Remember, we were trying to prove that A and B are parallel. Well, if we have two vectors that have an angle between them of 0 degrees, then that means they're going in the same direction, which means they're parallel. If they have an angle between them of 180 degrees, then that means that they're going in opposite directions on the same line. Therefore, they are parallel. So we can say, therefore, vector A is parallel to vector B. And that's what we wanted to show. Okay, then, likewise, the other way around. It's frozen again. If we start out with A being parallel to B, if that's what our given information is to start with, then we know that, therefore, the angle between them is either equal to 0 or 180 degrees. And you can see that this is pretty much just the reverse of what we just did. And so, therefore, if we look at this formula for the cross product, A cross B is equal to the magnitude of A times the magnitude of B times the sine of either 0 degrees or 180 degrees. But it doesn't matter, either one. If it's sine of 0 or sine of 180, we just talked about the fact that that's just 0. So this becomes 0 on the side. So now notice that what we have is the cross product of our two vectors, the magnitude of the cross product of the vectors is 0. So if the magnitude is 0, that means that A cross B has to be the zero vector. It's the only vector that has a magnitude of 0. And that's what we were trying to prove. We were trying to prove that the cross product would be 0. So something I want to point out here is, remember that with dot product, when the dot product was 0, our vectors were perpendicular. But when the cross product is the zero vector, then our vectors are parallel. And again, you can see some, kind of strange correspondences between these two things, between the dot product and the cross product. Some sort of backwards things. Remember we said here, this was cosine of theta, this was dot product. Well, this is cross product and sine of theta instead. So we're seeing some parallels. And that's why I have this comparison chart that we will talk about tomorrow, because there are a lot of things that are the same, kind of the same with dot product and cross product, but then there are a lot of things that are a little different. So we'll talk about this tomorrow. So your homework tonight, or what you should do now after you've watched the videos, and you should work on this in class and you can work with each other, is to do these two U-try problems, do them on a separate sheet of paper. I do want them turned in, and then here are